Okay, the first question in the second tutorial sheet reads, the position of a particle is given by this function, x of t is equal to 3.0 t squared plus 0.5 t raised to the power of 4 meters. So yeah, this is just a function of distance or displacement in a way. So what we have to do, we need to manipulate it using some mathematics, specifically calculus at certain points. So let's get into it. Okay, so we have this function where x of t is equal to 3.0 t raised to the power of 2 plus 0.5 t raised to the power of 4. Now, this is just showing that the displacement at a given time is given by this, and that m is just the unit meters. Now, for the first part, they're telling us to calculate the average velocity between 1 second and 3 seconds. So let's take the initial time as 1.0 seconds. So we're going to get this formula, and then we're going to substitute the value for t as 1. So that's x of 1 is now equal to 3, let's replace that with a 1 squared, plus 0.51 raised to the power of 4. So yeah, this is just a 3. And 1 multiplied by 0.5 is a 0.5. It's like half of 1. And that gives us 3.05 meters as the initial displacement. Next thing, we're going to say x of, what was the unit? Yeah, here where t, or the final time, was 0.3 seconds. So that's x of 3 is equal to 3 raised, so 3 multiplied by 3 raised to the power of 2, added to 0.5 multiplied by 3 raised to the power of 4. Okay, that's going to give us 9.7. Then that's going to be plus 3 raised to the power of 4 multiplied by 0.5, that's like 81, multiplied by 0.5, which is going to give us 40.5. And adding this together is going to give us 67.5, which is also in meters. Now what we have to do in order to first find the average velocity, we need to use this formula, the change in displacement over the change in time. So the change in displacement is going to be the final velocity, the final displacement subtracted from the initial displacement over the final time subtracted from the initial time. The final displacement was 67.5 subtracted from the initial displacement, which was 3.05, over the final time, which was 3 minus the initial time, which was 1. So this eventually is going to give us 67 minus 3.05. Wait, this was 3.5, not 3.05. So that gives us 64 over 2, which eventually gives us 32 meters per second. And that's how we find the average velocity. Okay, now let's look at the second question, which is saying calculate the average acceleration at t is equal to 1 second and 3 seconds. Okay, just from the understanding of this question, we're calculating the average acceleration at t is equal to 1 second and 3 seconds. It's not telling us to calculate the average acceleration between, so which means we need to look for two separate answers. But the thing is that we've been given displacement with respect to time. being equal to 3t squared plus 0.5 t raised to the power of 4. So first thing, we need to change this to velocity. So velocity is equal to dx dt. Yeah, the differentiation of x with respect to t. So this is where we need to use the calculus. So we need to say the differentiation of this equation, 3t squared plus, let's say, 1 over 2 t raised to the power of 4 with respect to t. So in order for us to differentiate, we multiply the power by the coefficient. So that's 2 multiplied by 3, which is a 6. And then we reduce the power by 1. 2 minus 1 is a 1. So we don't show that. So here we're going to do the same. 4 multiplied by 1 over 2, which is 2. Because half of 4 is 2. Then t raised to the power of 4 minus 1, which is a 3. So this is velocity. Now in order for us to find acceleration, acceleration is equal to dv dt, the rate of change of v with respect to time. So dv, v is 6t plus 2t cubed with respect to time. So same thing, 1 times 6, which is a 6, t 1 minus 1, which is a 0, t to the power of 0 is 1, so yeah, just leave the 6. Then that's 2 times 3, which is a 6, and t 3 minus 1, which is a 2. Okay, so this is acceleration for us. So acceleration is 6 plus 6t squared. Now in order for us to find the acceleration when time equaled 1, we just say acceleration at time equals 1 is 6 plus 6, 1 there squared. Yeah, 1 won't even do anything. So that's 6 plus 6, which is giving us 12 meters per squared second. Then when the time equaled 3, we're saying 6 plus 6 raised to the power, plus 6 multiplied by 3 raised to the power of 2. 3 raised to the power of 2 is 9. 9 multiplied by 6 is equal to 6 plus, that's 9 times 6, which is 54, plus 6, which is 60 meters per squared second. So that's the time at t equals 1, and so that's acceleration at t equals 1, and that's the acceleration at t equals 3. Okay, now let's look at part 3 of the question, which is telling us calculate the instantaneous velocity at t equals 2 seconds. Instantaneous meaning at that exact same instance. Well, we already established that velocity is equal to dx dt, and we found that that equation is giving us 6t plus 2t raised to the power of 3. Now we want to find the instantaneous velocity when t equals 2 seconds. So where there is t, we replace it with a 2, and we're going to say 6, 2 there, plus 2, another 2 raised to the power of 3. 6 times 2 is a 12, plus 2 raised to the power of 3 is 8. 8 multiplied by this 2 is 16. So that's 16 plus 12, which is giving us 28 meters per second as the velocity. For that's part 3. And for part 4, we were being asked to find the instantaneous acceleration. We've also already established that acceleration is equal to dv dt. And the formula for acceleration is 6 plus 6t squared. So that's 6 plus 6 Remember, we want to find the instantaneous acceleration when time equals 2. So where there is t, replace it with a 2. And then that's going to give us 6 plus 12. Oh, sorry, this was squared. So that's 4 multiplied by 6, which is 24. Twice of 12. And that's 6 plus 24, which is equal to 30 meters per squared second. And that's how we find instantaneous acceleration as well as velocity.